So in this section, it's all about multiplying polynomials, and I didn't write down the goal because guess what the goal is? The goal is to multiply polynomials. Okay, so anyway, let's get right to it. Here we're multiplying monomials. What's a monomial? A polynomial with how many terms? A monomial has one term, mono, right? One. So we're multiplying two monomials together. Do you see them? Okay, this guy is I don't have parentheses here, but this guy is a monomial. Has one term, right? A term is defined by a product of a constant and a variable, or variables brought to whole numbered powers. That's a term, or a monomial. And then there's one monomial, and then there's another monomial. We're multiplying. The parentheses aren't necessary. If they're there, like I just put them in, you can drop them. They don't need to be there. Not for multiplying monomials. Now, before I actually do this one, I want to remind you of one of the laws of exponents that you learned about in your previous class, is that when you multiply two formulas with like bases, like, let's do a real simple one before we do this problem. Like if you multiply x squared times x cubed, do you remember what you do? You keep that base x, right? Because they're both the same base. And you add the exponents. So you get x to the 2 plus 3, which is x to the 5th. And that's a general law of exponents. If you have x to the m power times, got to be multiplication here, times x to the n power, then you keep the base and add the exponents. So it becomes x to the m plus n. And that's the law I was referring to. That's the law of exponents I was referring to. There are other laws of exponents. I'll mention one other right now. So two altogether. If you take, here's a generic example, or a specific example rather. If you take x squared and cube it, do you remember what you do? You keep the base x, but you multiply the exponents. So x to the 2 times 3, or x to the 6th. So the general rule is if you have x to the m, and then you take that to the n power, you get x to the m times n. That's the general rule. I don't want these laws to be a mystery to you. What does it mean when you say x squared? So let's go back to this first one. What does it mean when you say x squared? It means x times itself, right? What does it mean when you say x cubed? It means x times x times x. So when we add the exponents together, what are we doing? We're just counting the number of x's all together, aren't we? So 1, 2, 3, 4, 5. There's 2 here, 3 here, add them together, you get 5. So that's where the law comes from. I don't want that to be a big mystery. I want you to be able to think about it and figure it out if you forgot. Here it's a little bit harder to come up with, but I can justify that one as well, because when you look at x, let's look at the example, that's easier to think about. It's always easier to wrap your mind around a specific exponent rather than what m is, right? So think about it. X squared cubed really means x squared times itself, this outside exponent. How many times do you multiply x squared times itself? 3 times. And then if you use the first law twice, keep the base, add the exponents, you get x to the 4th. Keep the base, add the exponents, you get x to the 6th. Or even easier, and here's where the law comes from. You got like bases, right? X, x, x. You add the exponents. You've got repeated addition of 2. You've got 2 added to itself. So the answer is 2. X to the 2 plus 2 plus 2. In the exponent, you've got 2 added to itself 3 times, right? What's the definition of multiplication? It's repeated addition, isn't it? So one meaning of 2 times 3 is 2 added to itself 3 times. That's where the second law comes from. It's just from that repeated addition. Okay? So those are two laws of exponents that just have them at your fingertips. Recognize them, know when to use them, because they're going to come up a lot. There's others that we'll talk about when we need them. Okay, I like to review as we go instead of reviewing all at once. That's no fun. All right, so now that was your little review. Now let's do this problem, part A. Negative 2x cubed times 4x. The idea is you multiply the constants together and the like bases. But what justification is there for that? I mean, this x is here and this x is way over here. How do I multiply them together? Why am I allowed to do that? Well, the answer is the commutative property of multiplication. This middle multiplication, x cubed times 4, you can turn it around and make it 4 times x cubed. That's called the commutative law of multiplication. 3 times 5 equals 5 times 3. Commutative law of multiplication. So you don't have to write this step down, but I just want to remind you why it works the way it works. Why we can multiply the like bases together and then the constants together. So you can skip this step if you want, but the reason is we can switch this middle multiplication around and get in the middle 4 times x cubed. And now it makes more sense. Oh yeah, the negative 2 times the 4, they're right next to each other. I can multiply those guys together and get negative 8. What's x cubed times x? They're right next to each other. I can multiply them, keep the base, and add the exponents, right? The exponent's 1, so x to the 4. So there's actually no work that you need to show on this one. This was just so you understand why we're able to multiply the like bases together. It's because you can reorder the multiplication. No work on that one. You want to get to the point where you can do it without showing any work, in fact. And by the way, would it be a big deal if we put in another variable? So it's still two monomials multiplied together, but let's say we put in, I don't know, like a y squared there and a y to the 5th power there, so that the entire problem becomes, if I rewrite it in green here, negative 2x cubed y squared 4x times y to the 5th. Is that going to be a big deal? No, you're still going to get the same thing you had before, the same factors you had before. In addition, so you're still going to get negative 8x to the 4th, and then you're also going to multiply the other like bases together. If you were to rearrange the multiplication like we did up here, you'd have a y squared times y to the 5th on the end. Y squared times y to the 5th, you keep the base and add the exponents and get y to the 7th power. So if you throw in extra factors, that's how you handle it. You would, at least in your head, group those factors with like bases together and use that law of exponent that says when you multiply like bases, you add the exponents.